Very good morning, students.
Good morning, ma'am.
Good morning, Drupti.
Good morning, ma'am.
Good morning, Aditi.
Good morning, ma'am.
Good morning, Chandu. So, good morning to one and all. What's the date today? What's today's date?
3rd July, ma'am.
Yeah, 3rd July. Correct. So, you are ready with your books? Yes? You're all ready with your books, students? And the
Yes, ma'am.
accessories required to write? Okay, fine. So, let us have a discussion about the previous class. What was the discussion all about? Yes, tell me, what was the discussion? What we started learning? What we started learning? Yes? What we started learning? How do you define friction? Let me start. How do you define a friction? How do you define a friction? Tell me quickly. I need not ask repeatedly. How do you define friction, students? You can see the screen and tell me the answer. Give me the answer there.
Resistance offered to the motion at the surfaces of the bodies is known as frictional force.
Yes, it's a frictional force, the resistance offered against the motion, isn't it? Right. So, what are the different types of frictions do you find? Types of frictions? What are the
Static and dynamic.
yes, static and dynamic. Then static and dynamic
In dynamic, we have sliding and rolling friction.
friction. Is that I taught only Dhruti in the class, and what about the rest all?
Ma'am, fluid friction, dry friction, ma'am.
Hmm. What about others? Others can answer. It's not a mandatory. It is when your teacher is asking you, it's your responsibility to respond. Clear, students? You cannot be quiet. I'm telling you repeatedly, once this everything process completes with the vaccination, you will be on the offline mode. Correct? So you don't have much time there. We have to quick up.
Ma'am, first dose or completely second, ma'am?
Yes?
Ma'am, you have to get completely vaccinated or no? Having first
We'll
dose is
update you,
enough.
Chandu. We'll update you what is the steps or the levels, right? We'll update you. Don't worry. If you are vaccinated with the first dose, very good.
Ma'am,
Okay?
have done, ma'am.
Okay, fine. Okay. Now, what are the different types of frictions? Students, mass answer I want. You cannot be silent. Yes. It's very much seen on the screen. You cannot read that. The whole class I'm asking. What are the different types of frictions?
Static friction and dynamic friction, ma'am. Dynamic friction, two types, ma'am. Sliding friction and rolling friction.
Very good. Next, other student. Tell me what is a static friction? Define what is a static friction. Any other student?
Ma'am, the friction experience between two bodies when both bodies are at rest.
Yes, which are at rest. Any student, any other student, not the same student. How do you define a dynamic friction? Any other student, pick yourself. What about boys? Boys in the class? What is dynamic friction? Okay, I'll pick your names one by one. That would be better way to call upon, right? Darshan. Darshan. Darshan P. Darshampi not in class. Shafahad. Shafahad. Sunil.
Yes, ma'am.
Can you define what is dynamic friction? Looking to the screen. You have to
Ma'am,
read out.
it is the friction experience between two bodies when body moves over the other body.
Yes, very good. A dynamic friction, you find such a friction which is developed during the movement of the body. It can be either one of the body. If it moves, it undergoes dynamic friction. Next person. Pramukh. Pramukh. Pramukh, quickly, can you define what are the different types of dynamic friction?
Sliding friction and rolling friction.
Yes, can you define what is sliding friction?
The resisting force which opposes the sliding motion of one body or another body. The force acts in a direction opposite to the direction impeding motion.
Impending motion. It is movement. It's in the verge of motion. Impending motion. Next, Prajwal is not there. Manohar.
Yes, ma'am.
Read out what is rolling friction. Read out
Rolling
what is rolling friction. Rolling friction.
It is the friction between the two bodies when one body rolls over the another body.
Isn't it? It's a rolling friction. Now, how the friction is again divided into based on the contact surfaces, right? What are the types of contact surfaces? You find Gurumurthy. Tell me what are the different types of frictions you find on the definition of surface of contact based on the surface of contact.
Dry friction and fluid friction.
Very good. How do you define dry friction?
If the contact surface between the two bodies are dry, then the friction between such bodies is known as dry friction.
Yes, that is called as a dry friction. Correct. Now, next, what is fluid friction? Next person, Gulam.
Yes, ma'am.
Tell me what is fluid friction?
The friction between two fluid layer or the friction between a solid and a fluid is known as
fluid friction. Very good. Yes. Next we learned about what are the principles. Am I correct? What are the different types of principles? So how it is been categorized, the principles or the laws? What do you find? What are the different types of laws? Charan K, what are the different types of laws you find?
Force of friction always acts in a direction opposite to that
Laws
in
of
which
friction, there are two types, Charan. Laws of friction are two types. One is
yes,
static friction
static and dynamic.
Dynamic. Now you are telling about static. Okay.
Yes. The force of friction always acts in a direction opposite to that in which the body tends to move, and the magnitude of the force of friction is exactly equal to the applied force which moves the body, and the magnitude of the limiting force of friction bears a constant ratio to the normal reaction between the two surfaces in the contact.
Yeah. Then the force of friction
The
is?
force of friction is independent of the area of contact between two surfaces. The force of friction depends on the roughness of the surfaces in contact.
Very good. Very good. Next, before Charan, Chandu J.
Yes, ma'am.
Chandu J, tell me what are the laws of dynamic friction? You can read from the screen.
Yes, ma'am. I'll tell, ma'am. The force of friction always acts in a direction opposite to that in which the body is moving. The magnitude of kinetic friction bears a constant ratio to the normal reaction between two surfaces is in contact, but this ratio is slightly less than that in case of limiting friction. The friction force remains constant for moderate speeds but decreases slightly in the increasing speed.
Great, very good, Chandu. Next, what was the next discussion after knowing the laws? We started with the definition, isn't it? So what was the first definition what we learned? It's a limiting friction, isn't it? What's a limiting friction? Next. What's a limiting friction? Ashish. Ashish is there? I don't think so. Ashish is there. Vinay? Vikas? Vikas?
No.
Tell me now what is limiting friction? You can
The
read from the screen.
self-adjusting opposite and resisting friction which opposes the sliding motion of one of body over another has a limiting value, and the applied forces exceeds the value the body begins to move. The limiting value of force is called limiting friction, and the stage body is in limiting equilibrium and just on the verge of a motion.
Sure. Isn't it? You really you understood all the students. With the body which is under rest, it will experience some amount of friction, which is called as a friction only. But this body which is just starting or in the verge of or it is about to move will experience a friction called as limiting friction. Now what is next? What is coefficient of friction? Can anybody? I'll call the name before Vamshi. Vamshi Krishna is there? Pritam? Pritam Nayak.
Yes, ma'am.
Tell me what is coefficient of friction?
1 minute, ma'am. It is the constant ratio which the limiting friction x bears to be the normal reaction n, that is as shown in figure 8.2, where a body of weight W is in equilibrium under the applied force P and the frictional force F.
Yes. So we give this equation as mu is equal to coefficient mu is equal to F by N. Or can I write, student, F is equal to mu into N? Can I write this? Can I write this, students? Yes or no? By the definition of coefficient of friction, I define that mu is equal to F by N. What is F, students? What is F? Frictional force. Please remember, it is a frictional force. And what is N? What is N? Normal reaction. Please keep this in mind. And the diagram, you have to refer to this diagram. You can see the diagram. You can see this diagram. The total weight of the block, W. A person is moving, P. You find the force, frictional force, opposite in the direction of the applied load. And this is the normal reaction with respect to the opposite to the total load acting on it. So what is coefficient of friction, students? Coefficient of friction, when they ask you a definition, what is the coefficient of friction, you have to write that it is a constant ratio which the limiting friction bears to the normal reaction N. Okay. And you have to write the figure, then give the expression and tell that mu is equal to 0 for smooth surfaces. You are all remembering this, right? And I'll ask you now in the next assignment to write all these answers for the questions. So I'm not asking you to write down now quickly, okay? But you have to be alert in the class, right? It is very easy scoring topic. Okay, students? Fine. Now, what is angle of friction? Angle of friction? Angle of friction. Prashant Raj? Pawan Kumar? Pawan Kumar MB?
Yes.
Yes, tell me what is angle of friction? The definition is here.
The angle of friction for two
Contacting surface is angle between the resulting friction force
resultant. Resultant.
and the normal reaction normal.
Resultant of friction and normal reaction and the normal reaction end. It is denoted as phi. What is given as? You have to write this definition and represent this tan. It is denoted by phi, and you have to draw the diagram, right? So what is n? What is n, students? Again, repeatedly I am asking. What is n? Normal reaction is. Yes, normal reaction. How this normal reaction will come? Because of W, equal and opposite. What is F? What is F?
Frictional force.
Yes, frictional force, correct. Okay. Then what is R? You can see from the diagram. The resultant of frictional force and normal reaction, you find the R. So from the triangular concept, we give that tan phi is equal to F by N. What is F by N again for us students in the earlier definition? Earlier definition, what is F by N?
Mu.
Yes, what is that mu? Coefficient of friction. Okay, that is coefficient of friction. Now next, angle of repose. Nitish?
Yes, ma'am.
Tell me, angle of repose.
When a plane is inclined to the
Okay.
when a plane is inclined to the horizontal by a certain angle, the body placed on it will remain at the rest upon a certain angle of inclination. Beyond which the body just begins to move. The maximum angle made by the inclined plane with the horizontal when the body placed on that plane is just at the point of sliding down the is known as the angle of repose.
Repose. That's enough. That's enough. What do you understood, Nitish? What did you understand with that? Now, for example, I'll take a worksheet. Angle of repose. I'll drop one straight line and an inclined line. Okay. I'll keep a box here. So, do you expect this box to slide down at some angle of theta, 10 degree or something like that? It may not, or it may be. Now I'll tell it this box which is weighing as W will not slide down. It will not move down. So it is still at rest. Now, for example, with the same thing, I'll increase the theta value. Okay, students, I'll increase the theta value to 15 degree. I'll increase and I'll place the same block at the same position. Will the blocks may slide down? May or may not may. Correct. It may or may not be, but possibility is that. Okay, I will think that it is still at rest. Okay, even this condition is at rest. Now further, when it is not moving, I'll incline more. I'll increase the inclination. Let me say 20 degree. So this block will start sliding. Will start moving down or sliding down. So at this point, verge off or just started moving or sliding down, this angle we call it as angle of repose. Did you all get? Did you all get this, students? Did you all get? Did you follow? The class, students in the class, did you all follow? What is angle of repose? Am I audible to you?
Yes, ma'am.
The minimum angle at which the body starts to slide down.
Yes. Now, from the diagram, yesterday we started with the diagram, placing the same block, something like this. And remember, students, always the weight of a body will act straight. This will be straight. This will not be inclined. It will be acting straight down only. Okay. Now we have kept a box on an inclined plane at an angle of theta, right? And I'll drop this x and y axis along the plane itself, So applying equations of equilibrium, I'm repeating the yesterday derivations, right? So applying equations of equilibrium, first thing is, so we'll start doing, no problem, we'll start doing here. I'll apply equation of equilibrium. So summation of fx is equal to 0. What are all the forces you find? Do I need to resolve this force? Do I need to resolve this force, students? Do I need to resolve this force? This is along x-axis only. This is along x-axis. Correct. So no resolution is required. So if you don't follow, don't worry about this step. You'll get the same answer. So now how it is moving? To the right side it is plus, and to the left side it is minus. Correct? You should say yes or no in the mass. So plus F.
Yes, ma'am.
Plus F. Resolve this. Resolve this. W. When you resolve, what is the angle it is making? 90 minus theta. Right? So how it is moving? When I resolve, it will move to the left. W cos 90 minus theta. Yes or no? Is there any other force to resolve? Is there any other force to resolve, students? Okay, I'll wait for your answer, then I'll proceed. Till you answer me, I'll not continue a step also. Just before I said you had to respond to your teacher. You have to interact. Did you follow this step?
Yes, ma'am.
Yes. So I can simplify writing this as F is equal to W cos 90 minus theta. Correct? So F is equal to W cos 90 minus theta. What, students? What is cos 90 minus theta? In trigonometric function, what is cos 90 minus theta?
Sin theta, ma'am.
Sin theta.
Secant theta, ma'am.
Secant theta? Secant theta or sin theta?
Sin theta, ma'am.
Sin theta. So similarly now apply equation of equilibrium. Apply equation of equilibrium along Fy is equal to 0. Okay. Now resolve the force. Resolve the forces. What are the forces you find? N and W. Okay. How N is moving? How N is moving, students? Along the y-axis. It's moving along the y-axis. So doesn't require any resolution of N. So how it is moving? It is moving upwards. So upwards we take it as positive. Downwards we take it as negative. Correct? So upwards positive. So plus N. Then resolve W. What is the resolution of W? W resolution. Resolution of W, students. Along y-axis. See, if you don't reply no, you are irritating a lot. Without interaction, it is not possible to proceed with your class. Huh?
W sin 90 minus.
without interaction, it is not possible to continue the class, students. If you talk, then I'll continue. If you are not talking, I'll not. Tell me.
W sine 90 minus theta, ma'am.
Yes. W sine 90 minus theta. What are all the other forces you find for the resolution? How it is moving? How it is moving? Sine 90 minus theta?
Downwards, ma'am.
Downwards. So minus sine 90 minus theta, which is equal to 0. Therefore, n is equal to sine 90 minus theta. Correct? Or we can write it as n is equal to cos theta. So 1 divided by the other. So this is, sorry, W. This should be W, right? So 1 divided by, the equations divided by each other, we'll get it as what? F by n is equal to W sine theta by W cos theta. W cancels. F by n is equal to what? Sine by cos? Tan theta. But you find F by n is also equal to what, students? According to the previous definition.
Mu.
Yes, mu. Or you find tan phi. This tan get cancelled. I'll be left with theta is equal to phi. What is phi? What is phi? Angle of friction. Angle of friction, which is equal to angle of repose. They'll ask, prove that angle of friction is equal to angle of repose. Then you have to do the derivation. Is this clear? The derivation is clear. Yesterday I did, again I am doing it. Is that clear, students? They'll ask for 10 marks or 6 marks. Later I'll give you the assignment asking the same question. Okay, you'll be doing it and submitting. Okay, students, this is very, very important definition. Very commonly, repeatedly they ask what is cone of friction. Okay, to understand the lines, before that we'll explain what is the diagram. Imagine there are two blocks, A and B. They are the two blocks, correct? So these two blocks are moving towards the applied force direction. You can see here it is moving towards, right? The blocks are moving towards. When the weight of the block is, let me say W1 and W2 or something like similar blocks. Let me call it as similar blocks, W1 and W1. So the normal reaction is N. Here also the normal reaction is also N. What about the direction of force of friction? Opposite to the direction of the force applied. Correct? You can see this is the direction of the frictional force. Correct? See the direction of applied force and friction force. They are deadly. They are opposite to each other. And now I drop a resultant. What is this resultant? Resultant is with respect to F and N. What is F, students? F is a frictional force. N is what? What is N?
Normal reaction.
Yes, normal reaction. Well, now this is only cone of friction. It's a very giving a good pattern of cone. So only we are defining this. When I extend this resultant, it forms a cone. It forms a cone shape. It can be dropped into a cone shape. You can see here the angle subtended at the center of the cone. will be equal to the angle of friction. Angle of friction is equal to the angle of friction because they are parallel lines. And with the same side, it is making an angle of friction. And it continues to make the angle of friction with this cone also at the apex. So at the apex of the cone or the tip of the cone, you find total value of angle as 2 phi. 2 times the angle of friction. So did you understand the diagram, students? Did you understand the diagram?
Yes, ma'am.
31 students are there in class. Huh? Only 1 or 2 responses I get. Huh? To whom I am doing this class? To whom I am doing this class, students? I don't expect this. Did you follow the diagram? I'm asking you. The whole class has to reply. Did you follow the diagram? Is this clear?
Yes, ma'am.
Next, I'll talk to your basic science coordinator and tell about your class responses. Okay, this is how it's going on. You have to respond, Mane, respond. The cone of friction is defined as a combination of resultant. Combination, why do I say combination? Because we are combining two resultant. Combination of resultant of frictional force and normal reaction. This resultant is always with respect to the normal reaction and the frictional force. Obtained by applying forces in the opposite direction. Applied by the force applying in the opposite direction. Forms a circular cone. Forms a circular cone of angle 2 phi. Angle 2 phi. Total angle, which is known as cone of friction. Which is known as cone of friction. Again, I'll repeat, students. Like you have a combination of resultant. This resultant is obtained by due to the frictional force and the normal reaction. This frictional force is being obtained by applying the load in the opposite direction. When the two resultant meet, they form a cone like a structure which is having an angle of 2 phi, which is known as cone of friction. Is this clear, students? Yes or no? Yes. 30. What about remaining 30 students?
Yes, ma'am.
Yes.
Open your book. Open your book. We'll do a very simple problem to understand more. Quickly open your book. With a calculator. With a calculator. Ready? Ready, students?
Yes, ma'am.
Yes. Take down a block shown in the figure. See, students, that's all the topic of theory in this friction. You need not worry anything else about the friction. That's all. You have to be familiar with all that terms. Now, doing the problem is very simple. Only applying using equations of equilibrium, nothing else. You have to use only equations of equilibrium to solve the problem. Nothing new. It's very simple concept. A block shown in the figure is just moved, telling that it is in static friction. Just moved. If I say it is at rest, no, the friction will be almost zero. or very negligible value. So it has just moved by force of 200 Newton. But it is not in moving friction at the same time. Okay. The weight of the block is 600 Newton. The weight of the block is 600 Newton. Determine the coefficient of friction, coefficient of static friction between the block and the floor. Between the block and the floor. Take down this diagram. Quickly, once you have written, you please tell me. If you have finished writing, please tell me. We will solve this problem in our own way. The same methodology will follow. We will not deviate. Written? Okay. Now I'll draw the same sketch. Okay, this is a block with the flat surface. You find the block being placed here and 200 Newton. 200 Newton is applied at an angle of 20 degree. Correct? Anything else in the diagram? No. Okay, students, this is what they give. Now, what is given at first? What is given, students? What is given data? What's the data given? Am I audible to you, students?
Force, ma'am.
Yes, what is that value given? Force of 200 Newton. Force is given, already it is being said here. So I represent as P is equal to 200 Newton. Okay. Then the weight of the block is 600 Newton. W is equal to 600 Newton. Then what is to find? Determine the coefficient of friction between the block and the floor. Always they ask between the block and the floor only. Nowhere else. It is not possible to ask anywhere else. Only between the block and the floor only you find the friction developing. Okay. Friction is developed only when it is in contact with the other surface. So coefficient of friction has to be calculated. So to find coefficient of friction. How do you represent coefficient of friction, students? How do you represent? How do you represent coefficient of friction?
Mu.
Yes. Mu is equal to, what is the equation you have? Tan phi is equal to F by N is equal to mu. Right? Now, what is tan phi? This is angle of friction. What they are asking? Coefficient of friction. Isn't it? They are asking coefficient of friction, correct? In the friction. Yes or no?
Yes, ma'am.
Mu only they have asked to calculate. So from the angle of friction, we define mu as, we know that tan phi is equal to F by N, which is equal to mu. Or F by N is equal to mu, or F is equal to mu into N. Okay. Okay. Now I'll start drawing the free body. Initially, to understand, I'm writing all that, students. Once you follow, it is very easy to draw free body diagram. At first step, to draw the free body diagram. Now, what is a free body diagram? You'll be drawing X and Y axis. And X and Y axis. Okay. Now, what are the values? It is on the free body diagram. You'll be representing, students, the weight of the block. The weight of the block, W. How much it is? How much W is?
600 newtons.
600 Newton.
Yes. And then you find when some force is acting at an angle of 20 degree, 200 Newton. Okay. Then what else? What else you'll be drawing? That's how the free body diagram is. Where is the F and N is coming to picture? Remember the diagram. For every reaction or the load acting, there's always W is acting here. There's always equal and not equal. It is always normal reaction. There's always a normal reaction for the vertical load. For the vertical load, there's always equal, so not equal, opposite reaction to take up the load. So where the N value will be acting, in which axis it will be acting?
Y-axis, ma'am.
Y-axis. Did you understand how this N has come? It is acting as N. Now, what about, this is a friction problem. You should not forget. It's a friction problem, correct? So when there is a body is moving or applied force is in this direction, it is moving to the right side. How the friction will generate? How the friction will be generated? Yes, it will be generated in the opposite direction. So on which axis it is acting? On the which axis it is acting? Yes, towards the left. It is acting F. Did you all follow with the free body diagram? Very easy. Always F and N are perpendicular to each other, students. Right? These are all the applied forces. F and N are the forces what we are calculating. We are finding out the normal reaction and the frictional force. Now, how to start with such a problem? How to start with such a problem? Very easy. You have to apply equations of equilibrium. Apply equations of equilibrium. Very easy to go about. Now, tell me, what is the first equation of equilibrium?
Sigma Fx equals to 0.
Yes, sigma Fx to 0. Can you give me the direct equation now, students? Plus and minus. Can you give me the direct equation?
Plus 200 cos 20, ma'am.
Plus 200 cos 20.
Minus F, ma'am.
Minus F is equal to 0. So F is equal to 200 cos 20. What's the value?
187.93, ma'am.
187.938.
938. So I can make it as 94. Next equation which I'll be using?
Sigma Fy equals to 0, ma'am.
Yes, sigma Fy is equal to 0. Here upward moving forces positive, downward moving forces are negative. Tell me.
Minus 600 plus normal
Minus
reaction
600
plus normal reaction equals to 0, ma'am.
plus normal reaction. That's all. What about 200? You have to
Plus
resolve.
200.
Plus or minus? Plus 200 sine 20. Tell me now. N is equal to 200 sine, sorry, this is minus 200 sine 20 plus 600. What is N? What is N? Calculate N value.
$531.595.
531.595.
5.
Okay. Do you get others? Others, do you get the same answer?
Yes, ma'am.
Now, therefore, what is the coefficient of friction? Therefore, coefficient of friction mu is equal to, by definition, it is F by N. F is 187.94 divided by 531.595. What's the answer you get for mu?
0.3535.
0.35.
35.
Okay, 3535. I can write it as mu is equal to 0.35. Any doubt, students, here? Any doubt? Any doubt?
No, ma'am.
Is this clear?
Yes, ma'am.
Okay, now, fine. You have to put your all hard work, students. This is a peak time of your semester. You cannot be easygoing. You have to be very serious with your studies. So with this, I'll end the class. I'll take your attendance. Once your attendance is given, you can leave the classroom. Okay, students? I'll take from upside down. Darshan. Shafahat.
Present, ma'am.
Shafahat presenter. Sunil.
Ma'am, present, ma'am. Present, ma'am.
Ma'am, present, ma'am.
Who is presenter?
Sunil, ma'am.
Ma'am, Manohar present, ma'am.
Now you are all calling each other. Hey, madam, attendance karita daro. You are talking, huh? Pramukh.
Present, ma'am.
Jwal. Manohar.
Present, ma'am.
Gurumurthy.
Present, ma'am.
Lam. Karan K.
Present, ma'am.
Nandu J.
Present, ma'am.
Ashish.
Ma'am, Gulam sir present, ma'am. Yes, ma'am.
Hi. Vikas. Bakshi.
Ma'am, Pramod Kumar present, ma'am.
Present, ma'am. Pritam present.
Pritam present. Shivraj. Charan K. Mute your mic. Prashant Raj. Pawan Kumar.
Present, ma'am.
Nitish.
Present, ma'am.
Mokshagna. Mohit. Manish. Madan? Harini?
Present, ma'am.
Dhruva? Chetan? Bharat?
Present, ma'am.
Abhishek?
Present, ma'am.
Vimla?
Present, ma'am.
Vasant?
Present, ma'am.
Riparna?
Present, ma'am.
Saida?
Present, ma'am.
Rohit?
Present, ma'am.
Rishika? Rishi? Rishika? Rajesh?
Present, ma'am.
Akash? Pranav? Pawan?
Present, ma'am.
Karthik? Pratik? Mohit? Kishan? Karuna?
Present, ma'am.
Dhanashri?
Present, ma'am.
Geeta?
Present, ma'am.
Shruti?
Present, ma'am.
Karanes?
Present, ma'am.
Likit?
Present, ma'am.
Aditya?
Present, ma'am.
Aditi?
Present, ma'am.
Thank you all. Thank you.